Hello and welcome again. In this video, we are still doing subnetting, but this time we are doing subnetting differently. We are using a variable length subnet mask. So it's called VLSM. So VLSM, variable length subnet mask. So when you use variable length subnet mask, for example, let's say we have a network like this. Let's say we have a switch, and the switch is connected to, let's say, a couple of PCs on this LAN. And then we have a router here. Say this is R1, and R1 is connected to another switch right here. And okay, let's say we have a couple of devices here. And then we have another LAN, okay, right here. So we have three router interfaces, okay, as you can see right here. So this will be LAN 1, okay, and this will be LAN, let's say LAN 2, and this is LAN 3. So we have three LANs, okay, three LANs, LAN 3 here, okay. Let's say we are required to actually get, in the first LAN, we need, for example, let's say 100 hosts, at least 100 hosts on this LAN here, okay? In LAN 2, we need 50, let's say 50 hosts, okay? Let me delete this gibberish. Okay, so we need 50 hosts here, right? We'll go. Okay, 50 hosts. And in LAN 3, we need, let's say, at least 20 hosts. Okay, 20 hosts. How we can do that using this IP right here. So the question says, you have the 10.0.0.0/24 network. Design an IP scheme so that LAN 1 gets at least 100 hosts. LAN 2 should have at least 50 hosts. And LAN 3 should have at least 20 hosts. We are going to use a VLSM, variable length subnet mask. I'm going to show you why it's called VLSM, because the subnet mask changes all the time. Because the subnet mask depends on the number of hosts using this formula. For example, I'm going to tell you that, okay, here we have 7 bits as the host field, okay? Then 7 bits as the host field, that's actually /25 mask. And in LAN 2, we have at least 50, so to the power of 6, I think 64 is greater than or equal to 50. Then we have 6 bits, then it's /20. We have 6 bits, so /26. And then 20, 5 bits left should be in the host field. I'm calculating in your head right now, but don't worry, I'm going to go and elaborate and actually show you exactly how we can do that using VLSM. So let me grab my Notepad++. Okay, so let's get the Notepad++ right now. And right there, let me minimize my window. Okay, like this. And then I'm going to delete all this stuff right here. So the IPv4 that we have, it's 10.0.0.0/24. The original mask /24. So we have, okay, 24 bits in the network field, and we have 8 bits at the host field. So we are interested in the host field. So let's actually draw the host bits. So host bits are 8 bits, as you can see. So 8 bits right there. And then let me write the base of 2 on the top here. 64. Let me move this one a little bit and then inline the bits. So let's actually move the 0 here, and then 32 here, and then 16. Here we go. And then 8, 4, 2, and then 1 right here. So the VLSM, we're using this formula here that says number of hosts equals 2 to the power of h minus 2. In other words, we are looking for, okay, for example, for LAN 1, what we are looking for here, we are looking for, let's say, 2 to the power of h. Okay, 2 to the power of h minus 2 should be greater than or equal to 100. Okay, should be greater than or equal to 100. The h is the number of host bits. Okay, the host bits. So how many host bits we have? We have how many host bits? I mean, how many host bits need to remain in the host field in order to get at least, let's say, 800, right? So 800 right here. Okay. And then I'm going to actually ask how many bits. So I'm going to start in from here right now because we're concerned about number of hosts. So let's ask if 1 bit remain at the host field, is it enough? So to the power of h to the power of 1 minus 2, that's 2. 2. Okay, 2 bits. I think it's no. 2 to the power of 2 is 4 minus 2, 2, so it's not enough. 4 bits. 2 to the power of 4, 16 minus 2, 14. That's not enough. 5, I think you will get 30, so that's not enough. 6 bits, you will get 62. That's not enough. 7, you will get 126, okay, hosts, and 126 is greater than or equal to 100. So 6 bits, they need to remain, 7 bits, they need to remain in the host field in order to get at least 100, okay, hosts or usable IPv4 addresses. Let's actually bring the notepad here, and then let's actually, 1, 2, 3, 4, 7 bits, and then I'm going to draw a vertical bar right after the bit number 7 here, okay? And then what I can do, I can use the magic number. The magic number actually, it tells us, the magic number tells us that it's 128. So 128 minus 2, because we always subtract the network and the broadcast. So the number of hosts we get, 126 hosts per network. Or if you can't use the magic number, you can actually copy those bits. So this tells us the first LAN, let's say 1. And then I'm going to copy the bits, okay, and paste right here. So incrementing the last bit will give us the first IP, FIP. Incrementing all the bits except last one, we will get actually the last IP. And after the vertical bar, remember, after the vertical bar, incrementing all except last one after the vertical bar, we will get the last IP, and then incrementing all the bits, here, we will get the broadcast. And then we have the broadcast right here. Then I think we are good right now. So LAN 1, okay, LAN 1, it's 10.0.0.0, okay, and then what will be the first IP in LAN number 1? It's .1, and then the last IP, since we have 126, so if the first host will be 1, then the last host will be 126, okay, as we mentioned, and we can figure that out also using the magic number. And then 127 is the last, is the broadcast, and LAN 2, okay, so see what I'm going to do in LAN 2. I'm going to write the, so LAN 2, since our increment will go with 128, so it's 128, okay? And then I'm going to write 128 in binary here, okay? I'm going to write it in binary, so 128 in binary, there is 1, there is no 64, no 32, no 16, no 8, no 4, no 2, and no 1 right there. And then I'm going to ask again, how many hosts we need for LAN 2? We all the time start with the largest number, with the network of the largest number. So we're starting with the LAN 1 because it has the largest number of hosts all the time. If you start with LAN 2 or LAN 3, then you are going to get screwed, okay? You are going to actually not figure that out correctly. So what you need to do all the time, remember, start with the number of largest hosts and then move to next largest and next largest till you get all the networks. So right in 128, so this will be the network, and then copying all those bits here 3 times. So we didn't actually figure out how many bits they need to remain in the host field before copying. So that's 128, and then we ask, actually we need 2 to the power of h minus 2 is greater than or equal to 50 this time. So what will be the number, the host bits, in order to get at least how many host bits need to remain in the host field in order to get at least 50? So 5? No. 5 actually, the magic number is 32, minus 2 is 30, so it's not enough, then it must be 6. Then I'm going to draw a vertical bar right there, okay? 6 bits remain in the host field, and then incrementing this one will get the first IP, and then I'm going to copy right here and increment all. Let me draw the vertical bar right here. Increment all except last one. So, okay, so let's increment those. We'll get the last IP. And then copy once more for the broadcast. So our vertical bar is right here. And then we are going to actually increment all those bits here, okay, to get the broadcast. And then let's actually write down the LAN number 2. So LAN number 2 here, as you can see, the network is 128. So the first IP will be 128 plus 1, which is .129. Okay. And then the last usable IP is 128 plus, okay, those numbers here. So what do you think? Using the magic number, it's actually much easier. So 129, because our increments always will go with 64, as you can see here, okay? So we'll always go with 64, our increment, and the number of hosts we can get is 62. So 129 plus, or 128 plus 62 is 190, so it's 196 minus 2 is 190, 195 as a broadcast here. So 195 is the broadcast. So the last host must be 194 right here. And then the next LAN 3, the IP that we're going to use for LAN 3 is 10.0.0.196. Okay, and then yeah, and then we can write down the 196. So 128 plus 62 plus 62. Let me just okay. I think it's 162. 230 190. Yeah, I think it's 190. I think I'm doing something wrong in here. So this is 190, and 191 is the broadcast, and 192 is next available subnet that we can use. So 192, I'm going to write 192 again here. Okay, I'm going to take the vertical bar out because actually we are going to look for the number, how many bits need to remain in the host field. And also I'm going to change those right here. So I'm going to actually take this one out, take this one out. Don't cause any confusion, but you could write them actually separately. So here we go. And then let's actually, we're looking for 2 to the power of h minus 2 greater than or equal to 20. And that's the 5 bits need to remain in the host field. So 4 plus 1, it's 5 bits remaining. So this will give me the 128, 64, 32. So our increment will always go with 32, correct? So I'm going to draw a vertical bar here as well. And then I'm going to copy those bits right here twice. Okay, so I'm going to copy here. and copy here as well. Okay, so this will give me the last IP, and this will give me the broadcast. I need to just turn all the bits except last one here. Turn on all the bits except last one, and turn on all the bits right here. Here we go. And then we will get the broadcast. So what will be the first host? As you can see, 192 plus 1 is 193. And then the last host will be 192 plus 16 plus 8 plus, okay. So in general, looking at the magic number here is 32. So we're going to get 30 hosts. So 192 plus 30 is 192 plus 30. 192 plus 30 is 222. And then 223 is the broadcast. And next available subnet for us, if we need more than one network, or we can actually reserve them for future growth, is 224 right there. Now, why it's called variable length subnet mask? You see, when actually the bits in the host field remaining are 7 in the first LAN, so 7 bits remaining, so 32 minus 7, 32 minus 7, how much is that? So it's /25, okay, /25 here. And then in the second LAN, what we have 6 bits in the host field, so this is /26 because we have 6 bits at the host field. And then in the last LAN, we have 5 bits on the host field, so this is /27. So the subnet mask always changes. It's variably, okay, variable lint. The lint of the subnet mask changes all the time from /25 to /26, /27, and so on and so forth. And remember, for the exam, you need to actually remember the you need to master the remember the slash notation to the decimal notation. That's very, very important. So 128, 1 bit turned on at the fourth octet, and here 2 bits turned on at the third octet means that we will get 255, 255, all 26 bits turned on, 192, and then 255, 255, 255, 224, because 3 bits turned on, so 128 plus 64 plus 32. This is an extra stuff, and remember to actually write down the chart. Remember the 2 formulas that we mentioned here, and remember, actually, if you get confused, write the bits in binary. The bits in binary, if you are concerned about the, for example, /22, then you need to write both octets, the third and the fourth. If you are dealing with /15, for example, you are going to write the 3 octets. They are not going to ask such difficult questions, but at least, okay, /22, /23, you need to you need to know how to deal with that stuff, okay? So I hope this has been informative for you guys, and I would like to thank you for viewing.